Hello class, we're starting chapter 8 today. We're doing lesson 8.1, which is on applying exponent properties involving products. So we've got three different properties at the top of our notes. Okay, the first one is called product of powers property. So that word product means to multiply. Basically what's going on is if you have two powers with the same base. So what I mean there is these a's are the same. What you do is you add the exponents. So if you're multiplying two powers with the same base, you add the exponents. So for example, if I had x to the third times x to the 7, because they both have an x here, you are multiplying them, it's really like you just take the 3 and the 7 and you add those together. So 3 plus 7 is x to the 10. Okay, the second property is power of a power property. So what that means is if I have some power and I am taking it to another power, you're going to multiply those two things. So what I mean is if I have x to the third, and then I take that whole thing and I take it to the fourth power, okay, what that really means, on a side note, that really means x to the third times x to the third times x to the third times x to the third. There are 4 of them due to this 4 right here. So there's 1, 2, 3, 4 of them. Okay, so this property is really talking about you taking the 3 and the 4 and you multiplying them. So it's like saying x to the 3 times 4. X to the 3 times 4 is x to the 12th. Okay, so that's our answer. So you take these two numbers here and you multiply them together. All right, and the third property is power of a product property. So what that means is if I have two things that are being multiplied, and then you take that to some type of power, to some exponent, really what it's doing is you're kind of distributing that through. So an example of this would be like if I had x to the x times y, and I'm taking that to the third power. Well, this is the same thing as saying x to the third times y to the third. So it's basically taking this 3 and it's splitting it up into both of those variables. Okay, so just a very quick recap. If I am multiplying things with the same base, I add the exponents. If I am having them to a power, like this one, okay, then I'm going to multiply those two exponents. And this example, it's like distributing. Okay, so this is kind of awkward to explain in words, but I think it's easiest to explain by using examples. So let's take a look at example 1. It says simplify the expression. So right here I'm seeing that I am multiplying and these 2's are the same. That means I take the exponents and I add them. So this would be 2 to the 2 plus 3 is 5. This would be 2 to the 5th power. Okay, the next one. It's the same thing. I am multiplying powers with the same base, so I add the exponents. So it's w to the 9 plus 2 plus 7, which if I add that together, that would be w to the 18. Okay, this next one, letter C, the second 4 doesn't have an exponent, but our hidden exponent is the number 1. So it's the same thing again. It's like saying 4 to the 4 plus 1, which is 4 to the 5th power. And notice here, even though we had a number as our base, that number didn't change. It stayed there. Okay, the next one, this first -6 doesn't have an exponent, but again, it's our hidden number 1. So it's like saying -6 to the 1 plus 6. That means it's -6 to the 7. Okay, example 2, it says simplify the expression. So these examples are going to be like our second property that we were talking about. All right, we've got some power in it, and then that is being raised to the third power. So what we do in this case is we take our two exponents and we multiply them together. 2 times 3 is 6, so it's 5 to the 6. All right, the next one, same thing. N to the 7 times 2, times 2, which is n to the 14th power. Okay, we're going to do the same thing. Negative 3 to the 5 times 3. That will become negative 3 to the 15. All right, this one looks confusing because our base has z minus 4 in it, but really we do the same exact thing. We take the z minus 4, we don't do anything to it, and we do 2 times 5, which is 10. So our final answer is z minus 4 in parentheses to the 10th power. Okay, example 3. Simplify the expressions. Okay, so now this is similar to our property 3 that we were talking about above, where we can really just distribute that exponent to each of these. So we have 4 to the 7 times 16 to the 7. Now I do know that like 4 to the 7 is some larger number, right? And 16 to the 7 is some larger number. But because our whole lesson today is about exponents, we are going to leave our answer as this. I don't want us to multiply out 4 to the 7 times 16 to the 7. Okay, I want our answer left just as shown. Okay, and we're going to do the same thing here. We're going to distribute that 2 through. So we have negative 3 to the second power, r to the second power, times s to the second power. Now, I know I just got done saying that, like, let's not multiply this out, but negative 3 to the second power is such a small number in comparison to, like, 4 to the 7th times 16 to the 7th. So negative 3 times negative 3 is 9. It is okay to go ahead and multiply that and write 9 there. Now, if you wanted to leave it just as negative 3 squared times r squared times s squared, I will accept either way, okay? But this one I think is more clear. All right, the next one, I'm going to immediately put this negative out in front because I don't want to accidentally forget it. And then I'm going to take this 2 and distribute it through. So I have 3 squared times r squared times s squared. So 3 squared, just like the last one, it's okay to multiply it out. 3 squared is 9, right? And that negative was out in front. So I will accept either of these two. I do want to point out something here. There is a difference between this in letter B, okay, and this in letter C. I'm going to rewrite those two down. We have negative 3 squared in B, and we have negative, parentheses, 3 squared in C. Now, in the first one here, in this one, this negative 3, that is inside the parentheses. So what that means is we're taking negative 3 times negative 3, which our final answer is positive 9. In this second one, our negative is out in front. So that's saying 3 times 3 with this negative out in front. So our final answer is going to be negative 9. Okay, because 3 times 3 is 9, but the negative is still out in front, so we have to put it there. So there is a difference between those two. Okay, example 4. Simplify the expression. So we have negative 7 to the 8th times negative 7 to the 5th. I'm noticing that both of these have the same base, so I'm going to keep the base the same, and I'm going to add the exponents. 8 plus 5 is 13. All right, this next one, I have a hidden exponent here with this k. So we're going to add the exponents because we're multiplying them. So we have 3 plus 1 plus 2, which is k to the 5th power. Oops, excuse me, 6th power. Letter C. It looks like we're taking something and then we're putting it to the power of 4. So that means we're going to multiply those exponents. So we're going to get p to the 12th power. All right, in letter D, similar, we're going to multiply those two exponents. So we have q plus 8, and 2 times 6 is 12. So it'll be to the 12th power. Okay, letter E, we've got this whole thing to the power of 2. So we're going to distribute those two. So we have 8 to the 2, c to the 2, and d to the 2. Now 8 squared is a small number that we can just quickly do. So another way to write that would be 8 times 8 is 64. C squared, d squared. I do want to point out the difference between letter E and letter D. Okay? So the difference here is that in letter D, there is an addition sign inside the parentheses. So that's why we don't distribute this 12 through. I do not take 12 to the, or q to the 12th and 8 to the 12th. I don't do that. But in letter E, everything inside the parentheses is multiplied, and so that is why I can distribute that 2 through. So there is a difference there, and that's why. Okay, letter F, there's a negative out in front, so I'm going to put that right there, and then I'm going to distribute this 3. So I have 5 to the 3rd and z to the 3rd. All right, 5 to the 3rd is 5 times 5 times 5, which is negative 125. If at any time I am moving too fast or you want to try a problem on your own, please do actually pause the video and re-watch a segment, or just pause and think for yourself before watching for the answer. Okay, letter G, I'm going to distribute that 4 through. So I have 2 to the 4, and then here, be careful, I have x to the 5, but then that is taking it to the 4th power, so I have a second step to do. 2 to the 4th is 16. That's like saying 2 times 2 times 2 times 2, so that's 16. And then this right here, I still have to multiply those two exponents together. So that's x to the 20th power. Okay, and we've got two that I'm going to call a challenge. So if you want to watch how do we do these, all right, we are going to distribute this 4 through. So I'm going to do that first. We have 3 to the 4th, and then we have y to the 3rd to the 4th power, and then times y to the 5th. Okay, now we can simplify those two. 3 to the 4th is the number 81. 3 times 3 times 3 times 3 is 81. So this becomes 81. I need to multiply those two exponents, so we get y to the 12th, and then times y to the 5th. Now I can simplify these two together. We have 81 times y to the, and since these two are multiplied, you add the exponents. So 12 plus 5 is 17. So it becomes 81 y to the 17. All right, last one. Thanks for staying with me. I'm going to go ahead and I'm going to distribute this 3 through. I'm going to bring this x squared down. So we have 3 to the 3rd, and then we have x to the 3rd, and then to the 3rd again, because this 3 got distributed. And then we have y to the 3rd. Okay, so I'm going to bring this down, this x squared. 3 to the 3rd power is 3 times 3 times 3, which is 27. So if you ever get a number that's smaller, it's okay to just write it out, what it actually is. This one right here, we have to multiply those two together because they're, right now it's an exponent. So that becomes x to the 9th. All right, now let's see if there's any like terms. I'm going to circle the x's. I'm going to underline that 27, and I'll put a box around the y to the 3rd. So let's put the plain number out in front, the 27. Now x squared times x to the 9th, because they are multiplied, you add the exponents. So that's going to become x to the 11th power. And there's nothing I can do with the y to the 3rd, so I just write it down. All right, that is lesson 8.1.